in chemistry and science, measurements are used to gather quantitative information, which is called data. So we're going to be doing that in lab next week on Tuesday and Thursday, the measurements lab. So this is going to help us prepare for that measurements lab, and we'll see a lot of this material again in that lab. So when you are measuring something, you're typically using a measuring instrument. You're going to use a ruler to measure length, dimensions of length and width and height. Length and width and height. You're going to use a beaker and a graduated cylinder to measure liquid volumes. And you would typically use a thermometer to measure temperature. So those are all measuring instruments. What they all have in common, they're not just that they're used to measure, but they also have in common marks on them. So on this slide, you can see that these are some examples down below of rulers. And they have, the top one has a single mark on it, just one mark with a number 1. So when you have a mark with a number next to it, or even marks without numbers next to it, like on this lower ruler, those are called certain digits. All those marks. You are certain of the number value represented by this mark, this is 1, or by this mark, this is 10, or this mark, this is 100. Okay, but even the mark without a number next to it, just to the right of 100, let's look at this mark actually, a little bit over. This is 5 over. It's halfway between 100 and 110. This is 105. Okay, so the certain digits are the marks. Some of those have number values with them. So you are certain of those values represented by those marks. The other thing you have are regions between the marks. So regions between the marks, you can actually estimate the value. And so, for instance, on this blue line above, let's take this blue line and use this as an example, where we want the length of the line from here to here. And let's just use this, drop this straight down. That's about as straight as I can do right now. And measure this. So assuming this is a ruler from 0 to 1 and let's say centimeters. So you've got this green line is somewhere between 0 and 1. We can see that it's not close to 0, it's closer to 1. So your estimate of what this, the estimated value of this is maybe, I'll say 0.8. And we need units of centimeters. You can't get much better than that because we don't have any more marks on there to help us. So even this second ruler, this green line falls between 8 and 9. So we have the 8 is further, or then this line is closer to the 9. So maybe you could say this is 8.8. Still not much better there. Okay. But on this ruler, we've got a bunch of marks, and these smaller marks do represent more measurement potential. However, they are marks that we need to really look at first. So let's see, we've got this is 10, 20, 30, 40, 50, and you can see here that this is a mark between, I'm going to take over here, between 50 and 60. There are 10 marks. So this single mark right there would be a tenth of the way between 50 and 60. A tenth of the way between 50 and 60 is not 0.1, but it's actually 1. So you could take 1/10 of 10 between 50 and 60. So that mark would represent 51, just as this was 105 between 100 and 110. So 51. And what you can read between the marks, I'm going to blow this up actually, is that you would have this region that is between 50 and 51 in here, which would be represented by 50.5, okay, is in here. That would be the estimated value is in that region. So make this smaller. And that is between the marks. That's called the uncertain digit. It's estimated and it's between the marks. Okay, so all of these actually all measured, and this would be 50.5, and this would be, let's see here, that green line, I've got 86, 87, 88, maybe 0.5 and centimeters. All of these measure to the same 0.1 centimeters. That's 1 decimal place out. That's 1 place to the right of the decimal, and so that's the tenths place. None is more accurate than the other. They all have the same precision, and they are all to 1 decimal place out. So to answer this question, which would you use to make the most accurate measurement? Even though this has the most marks, it actually is, they're all having the same precision, which is to 1 decimal place out. Okay, so in general though, the more marks on a measuring instrument, the more precise it can be. And so looking at, this is a graduated cylinder. A graduated cylinder is used to measure liquid volume. So we're going to be using a graduated cylinder and a beaker to measure liquid volume in lab next week. And this is liquid volume in units of milliliters. So liters are the SI units for volume are in liters, but in lab we're typically using smaller amounts. That's a milliliter, milli being 10 to the minus 3 metric prefix liters. So when you are given a measuring instrument, you're going to start with looking at it. And looking at it is, you're going to notice there's a bunch of lines on it. So those are lines, those are marks that represent certain digits, and also those can be marks with numbers or marks without numbers. So what we've got on this graduated cylinder are a whole bunch of marks. Some of these are marks with numbers, but others are just regular marks. Those are all certain digits. But the precision has to do with the uncertainty. So every measurement value has a degree of uncertainty. It's due to mostly the precision of the measuring instrument. That's what can be read between the marks, is that uncertainty. So it's also in part due to the skill of the person measuring. Do they know what they're doing? For instance, if this is a graduated cylinder, a couple things about the graduated cylinder is that this is a curved meniscus. This happens for liquid water when it's in a narrow container like this graduated cylinder or a test tube, or if you continue on in Chem 10 and Chem 11, you'll see a very narrow called a burette, or even more narrow pipette. Those are all ways to measure liquid volume, and what water does is it adheres to the inner sides of these narrow containers, and so it causes a curve. And so the way to read the measurement when you have the curved meniscus is you look at the bottom of the meniscus. That's the lowest part of the curve. Okay, so this would be draw a line straight across, and that where this bottom hits there is the measurement value. So this would be on here, the close-up image. This would be the bottom of that meniscus. So not the top, not where it hits the sides, but the bottom of that meniscus. So that's part of the skill of the person measuring it. They need to know that you're measuring the bottom of the meniscus. They also need to know that you should hold this at eye value, or at the eye level. So instead of looking at it from above or from below, you need to have your eye right at that bottom of the meniscus. So that's the skill of measuring this liquid volume. There's also conditions like lighting, or is this, on a flat surface? And the main factor, though, is not the person, it's not their skill, but it's the precision of the measuring instrument. You need to determine the precision before you take a measurement value. And why is that? Because the precision affects the measurement value in how many decimal places it has. Is it to the tenths place, or the hundredths place, or maybe not even any of those places, the ones place or the tens place? Typically, the precision of a measuring instrument is from looking at the smallest marks on the instrument and going one place better than those smallest marks. So for instance, on this graduated cylinder, you have the marks that represent the tens, but these small marks, these little guys here, represent the ones place. You could count up in this. This is 11, 12, 13, 14, 15, 16, and so on. So one place better than the ones place is going to be tenths place. Sorry about that. So you have the number values, the marks on this graduated cylinder. You got 10, you got 20, 30, 40, and these small marks in between 10, 11, 12, 13, 14, 15, 16, and continuing on up. These small marks represent the ones place. 11, 12, and 21, 22, and so on. So one place better is going to be the ones place and add a decimal, and this represents that 0, or the tenths place. That's the first place on the other side of the decimal. So this would be equal to 0.1 is this 0 held by what would change is 0.1, and this would be of a milliliter. So the precision is represented by this 0.1 milliliters. That is what you can read between those marks. So looking at this up close is, for instance, you've got 40 and then 41. So this would be 41. And one place better than that would be 0.0. That's what you could read between the marks, between 40 and 41, would be something like 40.5. And so this is that tenths place is the precision. It's also what you can read between the marks. It's also the uncertain digit. It's that region in between the marks. Okay, so usually the precision is one place better than the smallest marks that are shown.